So let's take another example. This is a rod. Let's go for, let's say, with three-dimensional one, so it'll be easy for us now. In which plane? Now the rod is along x-axis. The rod is along x-axis here. Now I'll apply a force and I'm making it to, I'll inch it about, the rod can rotate about z-axis here. It is hinged about z-axis. See, it can rotate about y, it can rotate about x. I'm making a situation, I'll put arrow like this. This is the axis of rotation. So here what happened, the inch I think I can't show here. So I'll just call this is the inch. So what actually you're discussing? It is similar to like this. If there's a mobile, then it can rotate about this axis only. What is the axis here? No, this is the mobile here. No, if it is rotating like this, so shall I say the axis of rotation is vertical? No, if it rotates like this, what is the axis of rotation? Will be horizontal. So this will be horizontal axis, or this will be much easier. If I do like this here, wait, this one. If I do like this, what is the axis of rotation? You'll call this horizontal axis, no? Then if it rotates like this, so shall I say again horizontal axis, x-axis, this will be. If it rotates like this, it is rotating about vertical axis. I'm class, I could have shown very best examples in the video. I don't know how it will appear for you. Now this will be rotating about vertical axis. It is rotating about horizontal axis. It can also rotate like this. So x, y, z. Suppose this is x, y, and this is z. No. So about any axis it can rotate. Now I'm making the rod to rotate about z axis here. I'll call that as the inch. So when I say inch means, you should be able to understand that when the rod is can rotate about z axis only. I'm putting a condition. Rod rotates. Rod is made to rotate about z axis only. Now let me apply forces here. Let me apply force here. So I'll apply force one which is parallel to z axis here. So I'll do this force F1. F1 is equal to say F naught K cap. Then I'll apply another force. F2 equal to F naught I cap. Then I apply another force which is parallel to y axis here. F naught J cap. This is very important thing which I am putting here. Try to understand, take help of unit vectors. It'll be better, easier. Sir, why you are applying force only at one end? Can you apply it anywhere? Yes, you can apply it anywhere. Now let's take another force. The other force F4, which is making an angle theta 4. So look at the F4. F4 lies in XZ plane. Let me give theta 4 only. Let me write. So how you define F4? F4 I'll define it as minus F naught cos theta 4 I cap F naught sin theta 4 K cap. Is it okay? Looking at this, what you can say now? This force is acting in z plane. No? Look at I cap, K cap. Okay, let's see that which forces will set up a torque. That's what I'm trying to, this one. There's a rod. Rod, it is free to rotate about z axis. About z axis. Rod is made to rotate about z axis only. So what is the axis of rotation? It's a fixed here now. Now, what about the torque by various forces? We'll take it. Let's go to the formula. I'll minimize it so that, okay then. Yeah, let's come back to this one. Torque due to F1. So let's take help of mathematics. We know mathematics. Torque 1 is equal to, this is O, this is A, no? OA bar, shall I write it? OA bar. In books, they're given mathematically. I'm trying to bring with some example. It'll be easy for you. What is OA bar? Li cap. Length of the rod OA is equal to how much? Let it be L. What is F1 bar? F1 bar is cross F naught K cap. I cross K. K cross I will be J. I cross K minus J. So minus L F naught J cap. Will there be any torque? Will there be any torque? No torque. The rod cannot rotate about that axis, no, because I'm making it to rotate about. If it is free to rotate, the rod is free to rotate S. This torque will try to rotate about Y axis. But what I'm saying inch, no, the Z axis is inch. The rod is inged about Z axis. If at all it can rotate only about Z axis. But how the torque is acting along J cap? So what you should say, mathematics is saying non-zero, but practically what pen? The rod cannot rotate about Y axis. About unless the rod will swing like this only. Or it can be about that axis, it will swing. Simplest way, if you see it should be either this one or this one. No, it cannot rotate about y-axis like this because it is hinged about that axis. So therefore, whenever if a body is set free to rotate about any axis, then you can define torque due to all the forces. But you should also be very careful about body which is fixed here, which is having fixed axis rotation. So here, shall I say that it's a fixed axis rotation? So the subheading will be torque about a fixed axis of rotation. And now what shall I say? Torque tau 1. It will not set up torque. This tau 1 what pen, because the body is not permitted to rotate about y-axis here. So then what you should say that one? Though it is acting what pen, the hinge will not permit the rod to rotate about y-axis here. So shall we put like this? The torque tau 1 will be nullified by the hinge. So as good as you can put, this is about z-axis, tau 1 will be 0. About what? About z-axis. But sir, already you calculate about z-axis only, but it's acting along what happened y-axis here. So it is not permitted to rotate. So you should put like almost equal to 0. So just say that it will not be set up. Torque tau 1 will be nullified or is not set up about z-axis. Nullified by the hinge or not set up. I think we have to be very careful about fixed axis rotation. Now, what about torque due to F2? Torque due to force F2. OA bar cross F2. What is OA bar? Li cap. This is F naught I cap. This should be 0. Any reason for that? F2 bar intersects axis of rotation. Okay, getting this one? Now let's come for F3 bar. What is the problem with F3 bar? We'll check it. F3 bar is acting along y-axis, no? So now torque. I'll minimize the diagram. Okay, try to see it. Torque due to force F3. This should be equal to OA bar cross F3 bar. OA bar is Li cap cross F naught J cap. High cross J will be K. So L F naught K cap. Torque, this will be 0 or non-zero. S, due to this, the rod will rotate. So what about the sense? About z-axis. The torque will be directed along positive z-axis, and the rod, what will happen, will have, there's a sense of rotation, I'm showing it. What about due to F4? How F4? F4 lies in which plane? XZ plane, no? This component of force, say no need to do. This component of force intersects axis of rotation. What about this? This force acts parallel to axis of rotation. Therefore, what will be the torque due to force F4 will be 0 about Z axis. So I'll put it. Though it is non-zero, see like a minus F naught cos theta 4 I cap plus anything will you say this? This will be I cross I will be 0. I cross case non-zero it is coming. Why can't you take this one? So it's a simple thing. This force somebody L by 2. Sorry, this is O OB, I'll write it. OB, I'll write it here. I didn't check it. L by 2 I cap, you write it. This force intersects axis of rotation. What about this force? This force acts parallel to axis of rotation. Okay, now shall we make some things clear? Some things clear. So altogether, sir, tau 4, what you should say? The torque tau 4 will be nullified by the inch. Nullified in means it not have any effect. Altogether, what is the conclusion we can make it here? If a force intersects axis of rotation, what is the torque by that? Will be 0. If a force acts parallel to axis of rotation, what about the torque? Will be 0. You can take example door, fan, all these are rotating objects are there, no? Try to apply force parallel to axis. So let's come to the, this is about the mathematics I shown. Let me take the door itself example. All these actually, once you get the idea of torque, no, rotation mechanics you can manage. I'm telling this one, rotation mechanics will be very easy for you. You can manage very comfortably. So let me take a door now.